Hello everyone, my name is Elijah Proctor, and today we're going to be talking about advanced hypothesis testing and performing a variance comparison analysis. So first we need to find a suitable data set with two or more populations with variances to compare from a reliable source. So we're using our heart disease data set, and this has two columns that we're going to be using. One is for the cholesterol levels of these patients and their target, which tells us whether or not they did or did not have heart disease. And so what we're doing here in this analysis is we're exploring the differences in cholesterol levels between these two groups, those who do have heart disease and those who do not. And our main question is whether there is a significant difference in the variability of cholesterol levels between these two groups, as this can give us important insights into the relationship between cholesterol levels and heart disease. So let's first go through our code. So first we have to load the data set, then we have to select our columns for analysis. So we have our cholesterol levels and then our target. When the target is equal to 0, that means that there is no heart disease. When the target is equal to 1, we do have heart disease. And so we're going to partition the data based on these levels. Here we're going to partition to two groups, and then we're going to perform our Levene's test. And so this is our stats.levene function, passing in these two groups as arguments, and this gives us our Levene statistic and our p-value, which we print. Then we have our box plot, which shows the cholesterol levels by heart disease status, and then also our histograms, which has our cholesterol levels for those without heart disease and with heart disease, with the KDE overlay on the histogram. So let's talk about our results. So here we're investigating the cholesterol levels of individuals with and without heart disease to see if there's a significant difference in cholesterol levels between the two groups. Our Levene's test for equality of variances gave us a value, or a p-value, of 0.344. And this indicates that there is no significant difference in the variances of cholesterol levels between the heart disease and non-heart disease groups. And this suggests that the assumption of equal variances is met. Our box plot compares cholesterol levels between individuals with and without heart disease, and this is showing similar distributions for both groups with some outliers present. Our histogram further illustrates the distribution of cholesterol levels within each group, and both of these histograms show similar spread through the group with heart disease. The group with heart disease has a slightly wider range and a few more extreme outliers compared to the group without heart disease. And so let's talk about our analysis report. And so we used our Levene's test to answer our research question. The test results showed an F statistic of 0.89 and a p-value of approximately 0.345, and this indicates that there is no statistically significant difference in variability of cholesterol levels between the two groups, and this suggests that the dispersion of cholesterol levels is similar regardless of whether or not they did or did not have heart disease. Our box plot, which is used to visualize cholesterol levels, does support the findings, and it shows similar distributions with only a few outliers in each of our groups. And then our histograms were created for each group to further explore our distribution patterns. And even though there are minor differences in the spread and central tendency, both of these groups show a somewhat normal distribution of cholesterol levels. And so the non-significant result from the Levene's test tells us that these minor differences do not substantially affect the overall variance. And our analysis that we perform here provides valuable insights. It emphasizes that the variability in cholesterol levels is consistent between those who do and do not have heart disease, and which can be used to inform future research or clinical decisions, where having an understanding of cholesterol level distribution is very important. So thank you for listening. That is all.